In the previous demo, we talked about procedural recursion, where we solved problems like counting down or dividing and conquering a grid, and we used logging to the console as a way to represent how that recursion was taking place, but we never returned any sort of value when we were recursing that would cumulatively add up. This is something we call reducing a dataset. When you use this approach, you have to not only return the base case, but also return the recursive call itself. Imagine a chain of command on a starship. The captain asks the commander for a status report. The commander asks the lieutenant, and the lieutenant asks the chief engineer. The chief engineer finds the data, which would be our base case, hands it back to the lieutenant. For that data to ever reach the captain, the lieutenant must hand it to the commander, and the commander has to hand it to the captain. In code, that handoff is the return keyword. To think about this happening behind the scenes with JavaScript, we can talk about it in terms of the call stack. Every time a function calls itself, JavaScript pauses the current execution and pushes a new frame onto the call stack, kind of like stacking plates in a cafeteria. In a reductive loop, these plates stack up until the base case is finally reached, and then it reverses and removes one plate at a time, passing those values down to the plate below it until the stack is empty and the final result is delivered. Let's do an example. We're going to have a function that recursively totals the mass for every single element in the array. I'm going to call this calculate total cargo mass. And we just need to pass in the index so that we can change which one we're adding on each time we recurse. So for the base case, we want to say if the index is greater than or equal to pod weights dot length, we will return 0 because there's nothing new to add at that point, but we do need to make sure that we're continuing to add on to whatever came before. The recursive case is going to have us return pod weights at the current index. And this is where we add on, passing along the next index, index plus 1. And as long as we start calling this the first time with 0, continuing to check the next index is going to get us all the way through this array until we reach the end, and then we'll just return 0 as the final number to add on. Now, because this function is designed to return a number, we need to store that. Let's create a new variable to call it and pass in 0 for the first index, and then let it recursively add up. And then we'll just log a sentence just to represent what that value is. Total fleet cargo mass. And then we'll pass in the absolute total mass in metric tons. Let's run it. And we get total fleet cargo mass 40 tons. So it added up 12, 8, 15, and 5 by recursing, changing the index each time, and eventually reaching the point where there are no more elements in the array, so it returned 0. All right, let me go ahead and make a quick commit. And we'll look at this practice. You're going to compute the time for a decaying orbit where a piece of space debris keeps losing 10% of its velocity. You'll have to think about what the base case is, and then also think about the recursive case and how to make that reduce all the way down to the base case by returning the result and then printing a sentence that uses that result in the console. That's it for this one. I will see you in the next one.